in the homework set. You'll see some Venn diagrams in the workbook page, and you'll see some times where they give you a problem where they don't give you the Venn diagram, but they give you the words, and you are forced to do a Venn diagram because counting is a part of probability. So in here, the 100 represents what?
The universe.
The universal set, total number of elements involved. The 15 represents what? Only in the left-hand circle. They belong only to the left-hand circle and not to anything else. The 45 relates to what?
Both
A and B, so that's the intersection section of the problem. And the 20 represents?
Only in B.
Only in B, or only in the second circle, the right-hand crescent of the circle. So how many of those 100 elements have you accounted for by the individual pieces of the circles A and B? Where are the missing values? They have to be outside the circle somewhere, right? So how many are missing? 20. Counting is a part of probability because you've got to fill in all the blanks before you can deal with the probability. Probability is a part to whole. And now, part of the reason for giving you a question like this is not only does it involve the counting, but it refreshes the Venn diagram, but it also keeps you honest with the notation that you're going to see a lot. First one reads how? A union B, implying all the things that are inside the Venn diagram or inside the circles?
Inside the circles.
Inside the circles. Inside the Venn diagram, you also have those 20 down there, don't you? Which means you have a total of 100. But they do want a probability, so don't stop at counting. Make sure you finish off the probability. So A union B gave you that 80 value that you needed to start with. That's how you found out what the 20 was. But it is a probability, so 80 out of the 100 items that are there, always the subset or the part of the Venn diagram that meets your need to the entire Venn diagram. And if that's a fraction, it's not reduced to lowest terms. To lowest terms, that would end up being 4/5. And that they want a decimal value. Would we need extra zeros at the end of the problem? Because the problem terminated itself. It won't penalize you if you put them in. It won't penalize you if you put a 0 in front of it. It will penalize you if you don't have the decimal place in the right place and if you didn't round off properly. So you have several different ways to be able to write the answer, but make sure you give the answer in the form that they want it to be. Second one. How does it read? A intersect B, the probability that the item is in both A and B at the same time, which is how many?
45.
Out of
100.
the 100, which reduced as a fraction would turn out to be 9/20ths, and as a decimal, it would be 0.45, and you wouldn't need the extra 0. Okay, so not a bad deal. And the last one then.
Not in A or B.
Not in A and not in B. That intersection symbol is an and statement. It's not in A and it's also not in B. So now it can't be 15, 45, or 20. But it has to be that straggler 20 that's on the outside of the circles out of the 100, which is a fraction reduces down to 1/5, or as a decimal value, that gives us a 0.2. And whether you put the extra zeros or not really is irrelevant. Now, it would be nice if they gave you some several of those Venn diagrams where it was already done for you, but more than likely they're going to give you things that are written out in words as well, evidenced by the fact that we had that workbook page where after the Venn diagram, the next problem was how many people could see Spanish and French or Greek and Italian or whatever it happened to be. So they'll still force you to refresh your skills and keep confident with Venn diagrams. Doesn't mean a Venn diagram is necessary for every problem, but it's always an alternative. Author line.